Hello, my name is Alejandra, and my partner for this project is Chucks. Our aim for the project was to locate the best viewing spots for stargazing in the Lower Mainland, BC, Canada. We decided to do this project because one, we love stargazing, and two, we were interested to see how light pollution impacts doing so. That was less important, but an interesting aspect to doing this project. We collected data from the Government of Canada and British Columbia. It included DMs, roads, obstacles such as buildings and facilities, water bodies, and tree cover patterns for the Lower Mainland. We also got a light pollution map, which was rasterized and georeferenced with the help of Professor Klinkenberg, and all of our data was either already in or converted to the 1983 Lambert conformal conic projection.
For our methodology, we began by rasterizing the vegetation shapefile and assigned tree cover values to various areas within the Lower Mainland based on the Vegetation Resource Index documentation as seen in Figure 2. Afterwards, we reclassified the light pollution map into classes that roughly resemble those of Image 2, where the values are in microcandelas per square meter and groupings of these classes roughly correspond to the Bortle scale. We used the digital elevation model taken from the Government of Canada to create slope and aspect maps of the Lower Mainland, and then established a hierarchy for the relative importance of the factors light pollution, tree cover, aspect, and slope, with light pollution being deemed twice as important as all the other factors. Afterwards, we used this AHP to create a suitability model and transform the data into using the following procedure. All of the fuzzy memberships were MS small, with standard deviation and mean multiplier set to 1. For the light pollution, the lower threshold was 0 and the upper threshold was 4.001 microcandelas per square meter. For the tree cover, the lower threshold was 0 and the upper threshold was 0.4. Aspect had a lower threshold of 0 and an upper threshold of roughly 360 degrees. And slope had a lower threshold of 0 and an upper threshold of 30.
After completing the map, we found that the best locations for stargazing were pretty much anywhere without light pollution. In the Lower Mainland, this is north of Greater Vancouver, we noticed that the mountains that you can see while facing north, while in Vancouver, seem to act as a light pollution barrier, and everything beyond them were much more suitable for stargazing. It was also evident that tree cover played an important role, as well as elevation. And interestingly enough, but also kind of a given, they went hand in hand, as with higher elevation came less trees. There are also quite a few limitations that we exposed while doing this project. The main one being that the resolution of our final map was quite low due to the processing power of our computers and the time frame. If we were to do it again for further research, we would likely use a more powerful computer and allow for more time. That way we would be able to get a much more in-depth location seeker for stargazing, as right now we can kind of just see the areas that are good, but we would like to expose more specific locations. If given the time to do more with this, we would also choose to buffer the roads and trails to intersect with suitability model in order to create a map of only locations that are accessible to the general public instead of all locations that are good. But overall, we are pleased to say that there are plentiful places to stargaze in the Lower Mainland, and we hope that next time you think to do so, you check our map to seek out the best spots. Thank you so much.